All right, yeah. Let's talk about building better API clients in Swift. As Ari already said, I am a member of the core team at CocoaPods, and I also work on the iOS SDK at Contentful, where we serve content to millions of users with an API-first CMS. And in fact, it was already used for the Signal website, and Greg here had some nice things to say about it. So if you're interested in using a CMS for your app, you should check Contentful out. All right, so why do we want to build better API clients? So basically we have this dichotomy between developers and users. We want to move fast and break things, but the users will give us bad reviews in the App Store if we do. And even though the app review for iOS has been pretty fast for the last couple of weeks with just like 1 day turnaround, it's still a day, and also not all of your users will update immediately. So if you ship bug, it's there for a while. So mobile apps need to be more reliable than the web. You might say you don't care, but let's build better API clients to help building better apps and make apps great again. So what does better even mean? At CocoaPods, last year we introduced this nice thing called the quality index. That's the circle you see on the right-hand side there when you look at a page for a particular CocoaPod. And it shows you how well we think the quality of a certain pod looks like. And this also influences things like the search ranking. So if you search for a certain term, the pods with a higher quality index will show up higher up. And if you click on this quality index thing in the CocoaPods web interface, you will see what this actually means for this particular pod. So every pod starts with 50, and then there's certain things that gives you points or decreases your points. One of those things is documentation. Another thing is having tests. And we also give extra points for being built in Swift, just because that's probably newer libraries. There are also things for like popularity and stuff like this, which you can't like super directly influence. So actually to get a good quality in terms of what CocoaPods thinks about your library or your API client, it's mostly about tests and it's about documentation. So we're going to look at a couple of different points when building an API client. We're going to look at what we can do when we develop it. We look at testing, we look at documentation and deployment. Let's start with development. This starts with the question, how do we actually talk about our APIs? Like, when we start implementing an API client, how do we know what we actually have to implement? And a nice thing we use at Contentful for documenting and describing our API is a format called API Blueprint. This is a markdown format for documenting and describing your API. And you have like things like URI templates there for the endpoints. You specify the parameters with examples. You can then specify specific actions like post, and then you specify the responses or also the request bodies and headers. So this lets you really nicely document what the API does. And from this, you can do a couple of things with tooling around it. The main thing is documentation. So there is a company called API who has created this API Blueprint format. And their main thing is that they provide this documentation on the web based on the blueprint. And there's also an API console and stuff like this, so it's actually relatively user-friendly. Another thing we get basically for free with it is testing if our API documentation actually fits the real API with the tool called Dread. You can run this on this API Blueprint file with some endpoint, and then we'll start calling all the all the actions that are described in the blueprint, and it will check if the responses you have documented actually fit the real responses. So we can check if the documentation and the real world are in line. What we additionally do at Contentful, we have a thing we call the API, what do we actually call it, Mario?
API coverage tool?
Right, API coverage tool. So what this does is for our different API clients, we basically check if all the, so we run the test suite and we check the endpoints the test suite has called against the blueprint to see if all the calls which are documented are actually also tested. So this is, for example, the output for the Swift SDK, where apparently some things are not called in the test suite. And using this, we can make sure that actually everything is implemented in the API client as we go forward. So if the API blueprint, for example, changes, the backend team implements something new, we will see this in the API client coverage. And yeah, it's written by my colleague Mario, who sits in the front, and he's actually doing our Android SDK, so if that's your thing, you can also talk to him. So another problem we might have when developing an API client is how do we actually map JSON responses to objects? Apparently that's the hardest problem in Swift development because there's like 50 libraries for it out there. And my personal favorite is a library called Decodable. Using it looks a bit like this. So basically what it does, it provides a new custom operator, this arrow. And with that, you implement a decode static function in which you pass in the JSON object that you get from NSJSON serialization. And then you create your structs from the JSON response. And it uses the Swift 2 error handling to bubble up any errors that might occur when constructing something. And yeah, basically you take your data from your API request, you put it into NSJSON serialization, and then you decode it with your custom implementation. So let's take a quick look at how this actually looks like. And for that, we're going to use a playground. And just a thing I mentioned here, if you're not familiar with the CocoaPod's Playgrounds plugin, it's actually a nice way to try out a certain CocoaPod in the playground. So let's switch over to the playground that I've already created prior to the talk. And we're going to just call the GitHub API and look like how we can map the JSON that we get from it. So let's do it. Going to do an NSURL session, data task with request. For that, we actually need a request, of course. For which we need a URL. And we're going to use my GitHub account. Going to just force unwrap the URL here. Don't do that in your real code. Oh yeah, it's an uppercase URL. We pass in the request. And then we get data, response, and an error from this. Yeah, we actually have to assign the task. We can do task resume. And if we get some data, let's use JSON serialization. JSON object with data, I think. Unfortunately, autocomplete. It's not working. And we have, just wait a second. We also have options. Just going to copy this from here because autocomplete is not working so well. Oh, of course, I copied it again. Sorry for that. All right, so now we have some JSON, and now we can use the decodable library to actually get something out of it. For example, we want the login as a string. And then we can print it. Okay, let's miss. There's still some error because we cannot invoke data task with request. Oh yeah, of course. We need to use the shared session here. And let's also collapse this and show this part. There's still one error here. Oh yeah. So as I said, this uses the Swift error handling for any errors that might occur. In this case, we just will fail when they occur. And as we see with this, we can just extract a string and actually be really type safe here. So in case this would not be a string, this would fail with an exception that we could handle somewhere else. And so this way we can actually make sure that we make the data that we get from an API type safe for Swift. Switch back to the slides. So yeah, as I said, the decodable library or something like this can give us the type safety. At Contentful, we have the problem that the API is quite dynamic. Inside Contentful, you can create your own content model. In this case, we have a doc content type with some parameters, like some fields like a name. And this is known to us, but it's not known to the API client. So it's really specific to each individual project. And in the API client, this entry type maps essentially to a dictionary which has fields. And those are of type any, which doesn't make really a good user experience, because then we actually have, first this is stringly typed, we're gonna ask for a name, what happens if it's not there, and we actually have to cast it to the right type manually. And this happens for every field, of course, and in Contentful these things can also be nested. And so this is not really a good way to work with it. The solution we use for this is code generation. We're using a library called Stencil, which is a little Swift library for expanding templates like the ones you see at the bottom. And using this, we have a template for an entity class, which is essentially a struct with its fields and the types. We know the types from the content model. It's just nothing that the Swift compiler knows. And we create an extension on this type with a static function that basically works like what we saw from decodable. And then there is a command line tool. You pass in your specific space and an access token, and it will generate code for you like this. For the dog that we just saw, we will have the name, description, and image in a struct. And there's actually a function that we can call to transform the entry type that we get from the API client to our specific struct. And this way, we again have an object that is really type safe. Another thing that worked really well for us for the API client is we offer a first-party offline persistence solution. So often this is something people have to build themselves, and we have a small library which basically is able to simply map stuff comes from Contentful to a local core data database. It doesn't actually do that much in terms of code, but it's a nice way for giving people a solution, a first-party solution to offline persistence. So something we also have to think about when building API clients is anticipating change, which is actually a central theme of REST. And for this, we are going to look at an API for creating polls. And on the web, this might look like this. So we have basically some HTML, and we're going to link to a thing that will be a form. So this offers us to create a question. We can fill in the form we get, and we can submit the form. And we can do something similar in our apps with hypermedia. There are two main formats for declaring hypermedia things for your API. One is HEL, the other one is Siren, and we're going to look at Siren. Basically, this is a JSON format for exposing the links that you have in your API. So each entity can have links to other entities. It will specify its properties, and it will specify the URLs and the HTTP verbs that are being used. And then there are actions as well for something like a form submission. And using that, we can change implementation details on the fly, because we have now encoded the links, we have encoded the HTTP verbs, stuff like this, so we can change the URI of a resource because we gave it a name that is independent of the URI. We can also change HTTP methods. For example, we can change from put to post. And we can change the content type as well. Or we can change the fields used in forms if we want to get really fancy. Then, of course, we need to also make sure that we can adapt our UI to this. So this is rather more advanced, I would say. So there's another Swift library we can use if our APIs support hypermedia, which is called Hyperdrive. And this is basically a generic API client for hypermedia. And again, we're going to look at it in a playground. So we're going to reuse the playground we already had earlier. Delete this stuff. And now we're going to use this Hyperdrive library. And first we're going to create a Hyperdrive instance. And then we're going to take this piece of code. So what this does, we pass to this enter method the root of the root endpoint of our API. In this case, we're using this polls API that we already talked about, which is an example for this kind of API. And we get back a result, which can either be success or failure. And in case of a success, we can look at the transitions the API gives us. So let's open the console. And this will probably be a little small. So basically, down here, we can see a set of transitions that the API offers us. So for example, we can request questions, /questions. We can also, actually, this is just one transition that it offers us for a question. So using that, we can actually go to the next step, which is, this was not what I wanted to do, which is looking at if we have a transition of a specific name. So you could say basically that we're trading the hard coding URLs to knowing about names. We now know that there is an endpoint called questions. It can have any URL, but we still have this knowledge that there is a questions endpoint, and we need to transition to it. And once we have this this transition, we can actually request it using Hyperdrive. Again, we get a success or failure, and then we again get this representer object. which you can print. And we can see now there's a bunch of stuff this offers us. This basically tells us about all the transitions we have from this questions endpoint, so all the possible questions. And from that, we can go further. So basically, we can discover the whole API from the root endpoint using hypermedia. And this allows us to make an API client that is more resilient to changes to the API, to the URL structure, to HTTP verbs, to content types, and stuff like this. So if you have an API that changes frequently, this might be something that you would look at. All right. Let's talk about testing. Basically, I only have a few things to say about this because testing an API client should be relatively straightforward. You know what the expectations are. What I would recommend is to stop or mark HTTP requests. There's a ton of libraries for doing this on iOS. My favorite ones are the ones at the top, Mockingjay or CCL request replay. The first one is written in Swift, the second one is Objective-C. And using those, you can basically, they are overriding the NSURL loading system, and you can tell them for, give it payloads for certain URLs that you're requesting. Essentially recording requests or providing pre-populated responses. So, but when we do that, we shouldn't forget about the real API that's also there. So a common error you would make is you create this test with a completely mocked response, and you never ran your test against the live server, and maybe you made a typo or forget something, or basically if you're writing the tests and you have written the API client, you will make the same mistakes in the tests that you made in your API client. So I would recommend recording the fixtures from a live server and also have the option there to run against production again and do that periodically to actually check if your API client not only works against some recorded responses, but also against the real API still. What is nice, once we do this kind of mocking or stopping of network requests, we can also more easily test error conditions. It might be really hard to produce a specific error condition with a live API, but it's really easy when we use a stopping library like Mockingjay. In this case, we just say, once, if this URL is requested with a put action, we return a failure. And we can also inject faulty responses and make our API client resilient against those. For example, in this case, we have a JSON that has a nil value, and we can test against those as well. Even though maybe the current API doesn't return these kinds of values, we can still make sure that our API client won't crash if it gets them. Another thing we can use when we do testing is Xcode code coverage. It's actually really easy to use since last year with Xcode 7. You basically go into your testing scheme, and there is a single checkbox you tick, which is gather coverage data, and you already have code coverage for your tests. If you want to create reports or run those things on CI or stuff like this, there's a Ruby gem called Slather that you can install, and that will basically work on the code coverage data that you produce from Xcode. So you still take that box, but this tool will basically post-process the results from Xcode, and you can use it, for example, to see the code coverage on the terminal, but it's also for like creating reports for all kinds of different CI systems, and also sending them to all these code coverage hosted services. And speaking about CI, personally, I'm a user of Travis CI, so this would be a Travis CI file for the Contentful API client. And you should make sure to test all the things that are important there. So I'm not only running the tests, I'm also running the code coverage. And I'm using the CocoaPods command liblin to make sure the pod spec is also still valid. If you provide any other kinds of like build products or stuff like this, you can all put them in CI and make sure that you continuously have the right results. And let's also talk about documentation. So Swift actually supports inline documentation that is fairly nice. So we can just put some documentation right in our code for each public method, and Xcode will show it inside. So if you hit, I think, alt-click it, you will see the documentation for a specific call you're looking at, and this will be taken from those inline code comments. There's a tool called Jazzy, which you can use to create HTML from your code comments, and this is also used by CocoaDocs, which is basically a hosted documentation system that you probably know about if you use CocoaPods, and this is used for Swift libraries to generate this nice HTML from the documentation. And at the top left, you also see the percentage of documentation, and you should really make sure to make that 100% for the public API. And one tip to actually creating this documentation is the VB Documenter Xcode plugin. Once you install it and you type 3 times the /, you will get auto-completion for this comment. So it will basically give you the parameter declaration, the return value, and stuff like this, and you just fill out those descriptions, which are actually, when you inside Xcode, those things you can tap through just as with regular autocomplete. Something that is also nice to offer for users of your API client is playgrounds. And playgrounds also offer the option to have inline markdown in them. So you can actually create an interactive documentation for your API client, or really any other library. I did the same for the Contentful SDK, and there's basically a playground where people can read the basics of the API and the library, while they can also change things inside this playground and run it and see it in action. So it's actually the simplest way to get to learn about the API client. I showed earlier the CocoaPods Playgrounds plugin. You can, once you have a CocoaPod for your API client, you can just use that to generate the playground, and then you put your actual stuff in there. All right, finally, we want to talk about deployment. Still, there's a lot of API clients out there which have this there. Download the SDK from our webpage. Nope, I don't want to do that. Most of you users will want a CocoaPod. We see this time and time again with companies who don't provide a CocoaPod. Someone else will create it, and at some point it will cause problems for you once you want to provide an official CocoaPod. So just do it from the start. So we also support binary frameworks. So if in CocoaPods, so if your API client for whatever reason has to be a binary, you can also ship that with CocoaPods if you don't know. But please ship dynamic frameworks. This is not so much of an issue with Swift because you cannot do anything else. But if you also happen to do Objective-C, please ship dynamic frameworks. They're supported since iOS 8, which is now 2 years old. But I would encourage you to consider open sourcing your API client. It helps us a lot at Contentful with getting much better bug reports from our users, the occasional fix, and stuff like this. It just made our lives much, much easier. And chances are there's not your real business value in the API client. So it doesn't really make sense to keep it closed source. You can also use the pod template to actually create the whole library for you if you're just starting out. So there's a command podlib create, which you can use, which basically uses a GitHub repo, which is a template. You tell it which language you're writing in and some other kinds of options. It would generate an Xcode project for you and the right kind of directory structure for a good library. And what's nice about it, it also supports Carthage. So with the output of the pod template, that also works with Carthage. And you can use that to create a binary that you can upload as part of your GitHub release to support users of Carthage and also people who might want to actually download a pre-built framework. But keep in mind that Swift has no stable ABI yet. And it also has recently been announced that it won't be coming with Swift 3. So it will be at least like 1.5 years probably until we get it. So this means if you provide a binary framework for your users in Swift, you have to make sure that you keep it updated, and also maybe you have to offer different versions, because it really only works if you and your users use the same version of Xcode in Swift. And also, don't forget Objective-C. There's still a lot of people out there writing their apps in Objective-C. And this is a comment from the Dropbox forums, actually, because Dropbox did this. They shipped version 2 of their API client without any support for Objective-C, and they used lots of new Swift constructs, so they will also not be able to be bridged to Objective-C. And there's a lot of people who complain about this. So still keep this in mind. At Contentful, we actually ship 2 API clients. We have one for Objective-C and one for Swift to actually offer a nice Swift interface. Another way can also be to write a wrapper for one or the other direction. So you might write your client in Swift and then provide a Swift wrapper, which only uses those functionalities which are bridged to Objective-C. Or you can completely write in Objective-C and use the default bridging that comes with, that Apple provides. But that would mean, of course, that you're not using any of those new Swift features and your users cannot take advantage of them. All right, so what have we learned? Use playgrounds and community-built tooling. Document your library extensively, test it, and also open source your work if you can. And do all of that to achieve that full quality index and provide a good experience for your users. Thank you.